To take two variables, okay. First we'll do n by 2 type of binary search algorithm. Okay. Pragati, binary search, yes, it's a kind of good idea. But the problem with binary search is that we don't have a sorted array here. The array can be of any type. Binary search algorithms can be applied only on sorted arrays. So it does not work that way. So, but yeah, 2 pointer. Okay. Two conditions. Merge sort. Merge sort, and we are not trying to arrange the array in an increasing order or decreasing order. We are just trying to say whatever the order of elements might be, you just have the sum has to match. That's it. No sorted, nothing. We can fix each array element, then find left sum and right sum. Okay. N minus 1. Okay. And this element need not be middle element always. It can be any element. Yes. Size of it. Check sum 2. Remember, it's not generally half of the array. Like left sum with 2 elements only, sum might be equal to 10 other elements on the right side. So it need not be a middle element always. Almost like 4 or 5 people have answered it, right? So I'll go with the answer. What I'm saying is for every element, answer can be any element. So for I is equal to 0 to n minus 1, what you'll do is calculate left sum. Let's say for j is equal to 0 to I minus 1. Calculate left sum. Okay. For say for k is equal to I plus 1 to n minus 1. Calculate right sum. If left sum and right sum matches, if left sum is equal to right sum, then break the array. You can say yes, there is an element. There is an element. Cool. Everyone okay with this one? Okay, good. Okay. What are time complexity and space complexity of this algorithm? Yes. Of n square. Sandip says yes. Saurav Sivaramakrishna says n square. Yes. Okay. What's about space complexity? Pragati, repeat once, ma'am. Sure. I'll repeat. Okay. Yes. Space complexity is off, and we are just using 2 variables, left sum and right sum. Apart from the input array. If you calculate the input array space also, it's off. Okay. So just to reiterate the algorithm goes this way. So we have to check whether there's an element such that sum of the elements on its left side should be equal to sum of elements on its right side. Right. Now, this element can be any element. So to check for every element, I'm running a loop from 0th index to n minus 1 index. For every index, I'm calculating what is the left sum. For right, I'm calculating what is the right sum. If both of them match, I'm saying yes, there is one element like that. Otherwise, I'll say there is no such element. Clear, Pragati? Is it okay now? Okay, done. Clear with time complexity and space complexity? Okay. So, can we do it any better? Think about it. Explain K loop. So K loop, basically what I'm doing is, if this is my I index, from I plus 1 to n minus 1, I'm calculating the sum. For the J loop, I'm calculating sum from I to I minus 1. Lalit, is it clear? Is it clear? Ma'am, I'm having difficulty using vector input. Okay. Did you check the yesterday's code? I have given. Lalit says yes. Even did you check the yesterday's code which I've put on the group? It has. It has a code to take in a vector to. Input to a vector. Okay. So try that once again. If not, let me know. I'll run and show. Okay. Okay. Cool then. Clear till now? We'll go to keep thinking about the better algorithm. Okay. Sandeep, I heard your answer. Okay. Yes, that's the answer. I want other people to also think once. Okay. Think for 2 more minutes. I'll give you a hint. Or keep thinking. So, if you see, for every element, we are calculating left sum and right sum. The difference between two left sums or difference between right two sums will be one element only. Like suppose you move from first index to second index. For left sum, you're adding something. From right sum, you're subtracting something. But in our algorithm, what are we doing? From first to last, we are iterating. From here to here, we are iterating. So whenever there is some repetitiveness in your algorithm, there is always a scope for improvement. J loop, we can start from middle element or starting element. Yes, this loop, the order of the loop, you can do I plus plus or I minus minus. That's your convenience. Okay. The idea is, suppose let's say I give you an array. I give you one, I've given you one array and said sum of first element. You have an array. Okay. Of 6. Of say 7 elements. Let's say our array has 7 elements. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3. Let me use a zero indexing to be clear. Okay. This is our original array. Let's say I gave you one more array also, for which I said this also has 8 elements, but 0th index is sum of elements from start to 0. For 1, it is 0th index sum plus 1 sum. For 2, it is 0 plus 1 plus 2. For 3, it is sum till 3. So on. I have given you such an array. Okay. Let's call this array pre-sum. Okay, because pre-sum, which I'm saying, element index is a sum of all the previous elements, including this element. That's what I meant by this array. Okay. Now think. Is there any other way to solve this problem? No. Array. I gave you this array also. Think. Any answers? What happened? Did you understand the concept of, did you understand what is meant by pre-sum? Same question. Question is the same. You have to check whether there is any element such that left sum is equal to right sum. Did you understand what I meant by pre-sum? That's the question. Now the question is, did you understand what I meant by pre-sum? If you understand the meaning of the array, I'll proceed with the algorithm. Otherwise, I'll repeat the meaning of the pre-sum. No, ma'am. Okay. Okay, cool. Let me explain what is pre-sum. Let's say pre-sum is an array. It's the name of the array. That's it. I have named one array to be ARR. I have named the other array to be pre-sum. I said pre-sum of I is equal to sum of all the elements in the vector ARR or in the array ARR, including ith index. I have given you this array. I did not ask you to compute or anything. I have given you this array also. Now is it okay? Did you understand the meaning of pre-sum? Or let me take an example and explain. Elements are 7, 1, 9, 2, minus 1, minus 2. Let's say this is your array. Pre-sum is basically 7. What is 7 plus 1? 8. 8 plus 9. 8 plus 9. What is 8 plus 9? 17. 17 plus 2. 19. 19 minus 1. 18. 18 minus 2. 16. This is pre-sum. Basically, sum of all its previous elements. 8 is the sum of 7 and 1. 17 is the sum of 7, 1, 9. 19 is the sum of 7, 1, 9, 2. 18, all the first 5 elements. 16, all the elements. Okay. Ankit, yes, your code is right. Sandeep says, okay, ma'am. Jatin says, compare pre-sum of I with pre-sum of size minus 1. Okay. Did everyone understand the meaning of this array? First, I want to know whether everyone understood this meaning. Okay, Ashish says yes. Okay. 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 Done. Done. Okay, great. Now, let's say I want to calculate the sum of these two elements. What is the, let's say, can I do 16 minus 19 to get the sum of these two elements? Yes or no? Okay. Can I do 19 minus 2? 2 is basically the element by element, and 19 is a sum till there. To get sum of all the previous elements, answer is 17. Okay. So is this the right sum? And is this the left sum? Now can I just compare and say whether an element exists or not? Okay, great. So I think now you understood the algorithm. The algorithm goes compute the pre-sum, which will basically take off and off. You keep adding, store them. It'll take off and time plus off and space. Okay. Then you iterate again, iterate through pre-sum. Iterate through array elements, or iterate from I is equal to 0 to n minus 1. And then you do if pre-sum of this ith index minus your ARR of I is equal to pre-sum of size of the array minus 1 minus pre-sum of I. If both are equal, yes, such an element is present. Else, if after iterating all, if you don't find any such element, then output no. Okay. Okay. How many of you understood? How many of you did not understand? If it's an yes, type yes. If it's a no, type no. Rajul says no. Okay. Pranav also says no. Okay. Okay, cool. I'll explain again. So I said, this is our given array. I have computed one more array. What is the definition of that array? Is that the ith index of that particular array is equal to sum of all the elements in the array, including ith index. Example goes like this. Suppose our array is 7, 1, 9, 2, minus 2, minus 1. Our pre-sum is I. What is I? Sum of all the elements before it, including this one, 7. There are no elements before it, so sum is 7 only. Now I have 1. So sum is 1 plus 7. I'm storing that in the first index of another array. Okay, and then next I have 9. What will be my pre-sum of 2? 9 plus 1 plus 7. It will be 17. Similarly for all the other things also. Now pre-sum is clear for everyone? Okay. Okay. Ashish, yes. Abhinav, Kapil, Saurav, Lalit. Are you clear on this one? Okay, great. See, our initial thing was we computed left. Our main task was to compute left sum and right sum. What does left sum mean? Sum of elements after this one. Left sum is sum of elements before this one. Let's take one example. Assume that we have created this array. Creating this array is very simple. You just need to do off and operation. So the code will go like this for the pre-sum. For I is equal to 0 to let's say I is equal to 1 to I is equal to n minus. Let me write clearly. For I is equal to 1 to n minus 1. Let's say pre-sum of 0 is equal to ARR of 0. From I is equal to n to 1, pre-sum of I is equal to pre-sum of I minus 1 plus ARR of I. This is how you can create a pre-sum. Clear? Okay. Now you have pre-sum. Suppose I said I have 19 here. For 19th one, I want to know the left sum and right sum. If I do 16 minus 19, answer is minus 3, which is actually the sum of minus 1 plus minus 2. That is 3. So when you subtract 16 from 19, you're getting the sum of all, you're getting the right sum. If you do 19 minus subtract the element in the original array, 19 minus 2, 17. 17 is actually the sum of all these three elements. 7 plus 1 plus 9. Minus 1 plus minus 2 is the sum of right. And this is the sum of left. So basically, if you do pre-sum of this index minus ARR of 5, which is basically the left sum. And if you do pre-sum of size minus 1. So this is 16. If you do 16, pre-sum of size minus 1 minus pre-sum till here. So sum of all these elements minus sum of elements till here will give you the sum, which is basically the right sum. You are comparing left sum is equal to right sum. Now is it clear? Lalit says no. Okay. Okay. Let me give you one more idea. Okay. Say your pre-sum is there, right? Your pre-sum till here. We'll say you have 4 elements only. Okay. So this last element, okay. Today my pen does not have charge. It is creating problem. Give me 1 minute. Let's keep thinking. Just 30 seconds. I'll write it again. For pre-sum, you have assume you have an array with 4 elements. Your pre-sum of 0 is equal to ARR of 0. Pre-sum of 1 is equal to ARR of 0 plus ARR of 1. Pre-sum of 2 is equal to ARR of 0 plus ARR of 1 plus ARR of 2. Pre-sum of 3 is equal to ARR of 0 plus ARR of 1 plus ARR of 2 plus ARR of 3. Suppose if I do pre-sum of 3 minus pre-sum of 1, what will happen? It's actually pre-sum of 3 is 3 plus 2 plus 1 plus 0. I mean indices here, don't get confused. Pre-sum of 1 is 1 plus 0. So this part will get cancelled, this part will get cancelled. You will be left with sum of, so it will become ARR of 2 plus ARR of 3. Try to understand this one and revise the algorithm. You should understand now, probably. Yeah. Okay. Now make sense? Cool. Great. Okay, then we'll take a 5 minutes break and then start with the new thing. It's 3:29. Break till 3:35, and then we'll start. Okay. Okay. Ma'am, please do more questions on subarray. Okay. Uh, okay. Let's see. Be of n. Space complexity, because we are using an extra space, that will be O of n. Okay, great. And what is the complexity of the cadence algorithm? Okay, I forgot to mention, if I mentioned the name or not, I don't know. We have used this technique, right? Largest sum of a subarray. The second algorithm which we have discussed. That's called as cadence algorithm. What are time and space complexities of this algorithm? I'll show you the algorithm. Think. Pragati says N. Kapil also says N. Saurav says N. And time complexity and space complexity 1. Okay. Jagadish also says N. Abhinay says N. Yes, you're right. So this is basically just one iteration over the array. We are not repeatedly using anything. We are performing some unit operations inside that one. So that will not affect the time complexity. That will not increase the time complexity. So basically time complexity is often space complexity. We are just using two variables. So that will be a constant space. Perfect. Okay then. Let's get back to our new problem. Given a sorted array, find the pair of elements such that sum of both elements is equal to x. Think about this one. Fix one element, search for other element, right? Two pointer, okay. Okay, Ashutosh, any more answers? Sandeep or whoever, Abhinay, Ankit, Jagdish, Saurav, Kapil, Pragati, Vishal, Saurav, Ashish, Rajesh, Jitendra, any more answers? Sorting and binary search from the set can be sorted. Okay. Let's discuss if there is any binary search approach later. Yes, binary search is one of the answer. Ma'am, using map. So map by using, you mean unordered map, right? Yeah, I saw your answer, yes. And one person is waiting. Ankit says one person is waiting. Okay. 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 Sorting two pointer, fix one element, search for the other element. Okay, right. Let me discuss one of first. Let's discuss one of the new approach. Let's say let's say we have 0, -1, 3, -2. Let's say this are 4, 5. Let's say x is -3. We have -1 and -2 with sum to -3. So these are the pair of elements. This should be the output. What else is for I is equal to 0 to n-1. For j is equal to I plus 1 to n-1. If ARR of I plus ARR of j is equal to the given sum yes, then yes, pair exists. Everyone cool with this one? Or any doubts? Remember one point. Here I'm not iterating from 0 to n-1 because I have already checked the previous elements. No point in rechecking. Suppose if I is 1, if you want to check j0, you have already checked when I is equal to 0 and j is equal to 1, you have already checked. So there is no point repeating the things. So we can go from next element to the last element, we can check. That's one statement if anyone are confused. Just a very, very slight optimization. That's it. Okay. I think I got good number of yeses. Okay. What is the time and space complexity of this algorithm? Yes. Half n square. What about space? Space is often. Clear? Anyone with any more answers? Clear? This algorithm, time complexity, everything is clear? Okay. Great. Now, see, there is one keyword in the problem. Our given array is sorted. In our first algorithm, we did not make use of the point that it is sorted. Okay. So, sorted array. Even if it's a normal array, even if the array is not sorted, this algorithm will work. But when the question says it is a sorted array, can we use any other technique so that we can reduce the time and space complexity? The hint is that if combination of two numbers sum is greater than required, you need to subtract some things. If the sum of any two numbers is less than required, let me write it little bit. Let's say sum of small x plus small y is greater than required sum, which means that you need to lower the elements. You need to lower any one of the element. If x plus y is less than, the required sum is more, which means that you need to increase either x or y, or you need to increase, or maybe you need to increase both. Is this clear? Binary search, Ashutosh Kumar, yes. Binary search is one of the solution. As we have not discussed the binary search yet, to be on the and so that everyone will understand, we'll discuss some solution which everyone will be able to comprehend. When we discuss about binary search, if you want to come back to this problem and discuss that approach also, we'll do it. Okay. Till here, everyone are clear? Saurav says yes. Okay. Done. Okay, good. Now let's say I do one. These are my elements. What is the area I took? 0, -1, 4, 2. Okay. 0. Okay. Okay. I made a mistake. What is the mistake? I made a small mistake here. Not even small, it's a considerable enough and good mistake. I said sorted array, but I did not give you a sorted array here. This is not a sorted array. But yeah, your first algorithm will work for arrays which are not sorted also. Okay. Let's say we have -1, -2 over here, 3 over here, 4, 5, and maybe 8. Let's say let me remove. No, I'll not remove anything. This is the example. Okay. The required sum which I want is, let's say my required sum is 4. Definitely it has to be a pair of numbers, not single numbers. Okay. Let's say I know the array is sorted. I initiate one pointer here. I initiate another pointer here. Let's call this a start pointer. Let's call this an end pointer. I said, what is minus 2 plus 8? 6. The sum which I want is 4. So now I have to lower some numbers. Minus 2 is already the least number. I can't lower it anymore. So what I'll do, I'll move this pointer here and check if the sum is matching. Okay. I have minus 2 plus 5. What is the answer? 3. But the sum which I require here is 4. 4 is only greater. Now I have to increase the value. From 5 also I can increase to 8, but I have already explored this one. So I can't increase, I don't want to increase this one. So then I'll push my start pointer to here. Now this is my step 1, this is my step 2, this is my step 3. What do I have? I have minus 1 plus 5. What is the answer? 4. That is the answer which I want. So I'll say yes, the pair exists. Cool. Did you understand the dry run of this algorithm? I'll write the algorithm anyway, but did you understand what I was trying to do? Prabhojit says yes. Okay. Sandeep says example one more time. Okay. Okay, cool. So basically what I was trying to do is, I was trying to start from the most least value and the largest value possible. And I was checking if the sum actually matches. If the sum is greater than the required sum, I reduce the value. From minus 2, I can't reduce anything. So from 8, I have moved to 5. Now, as soon as I move to 5, the sum has dropped a lot than the required one. So now I have to increase my value. To increase my value, I can do two things. From minus 2, I can push this to 1. From 5, I can push to 8. With 8, I have already experimented. It did not work out. So I'll try and push minus 1 here. If I push minus 1, now my first pointer is at 1 and second pointer is at 5. What is the sum? 4. That is what I require. Who asked? Sandeep, is it clear now? Okay, got it. Okay. Let me very roughly write the algorithm. Okay. Let's say my start pointer is at 0, end pointer is at n minus 1. I'll say while start is less than end. Okay. I have written some condition here. Say suppose you are iterating. You have crossed both these things. Your start pointer went beyond the end pointer. It actually means that you cannot now, even if the start and end elements swap, you're not going to find the pair. There will be no pair. Okay. So when we discuss the algorithm, when we were discussing the initial classes, we discussed two main points. The sequence of the algorithm is important, and the termination condition of the algorithm is also important. Where do you want to stop your algorithm? Once you realize start pointer has crossed the end pointer, no point in searching no more. There is no such pair. Okay. Now, if let's say your ARR of start pointer, start basically is my index, right? Plus ARR of end is equal to x. Yes, simply say return 1. Maybe my algorithm says return 1, true. If it's 0, return 0. Okay. And next, if ARR of start plus ARR of end is greater than the required sum. If it's greater than the required sum, what should I do? If it's greater, what did I do? From 8, I have moved to 5. I have moved the end pointer back. So do end minus minus. if ARR of start plus ARR of end, your required sum is more. Then increase the value. If you do not find anything, say return 0. False. Basically think that you're putting this algorithm in some function. It will either return 1 or it will return 0 accordingly. Okay. Clear? January says yes. Sandeep, yes. Okay. 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 I think everyone, most of, I can see only yes here. Okay, great. So these are type of algorithms are often called as two-pointer algorithms. Okay. Let me give you a hint about extension to this algorithm. Okay. Now I said pair of elements. Now I extend the question and say check for 3 elements. What will you do? Think about it for a minute. Any ideas? We fixed one element for each iteration and search for the remaining 2. First we find 2 and then add third. Check. Okay, and check, yeah. Okay, right. Saurav, you almost got to the solution. Check in you also. Okay, so basically what we do is, we have this algorithm, right? For above this algorithm, we run a for loop. Basically what we do is, we fix that element, search for the other 2 elements. Yes, like k plus b is equal to c. Exactly. Ma'am, what is the question? So our previous question was finding a pair of elements such that the sum is equal to x. Now we have extended that question and said, check if there are any 3 elements such that the sum of those 3 elements is equal to x. That's the question. So basically you do for I is equal to 0 to n minus 1. Your start will be I plus 1. End is equal to n minus 1. Use the same algorithm again. And you can say now your updated sum or new sum is x minus ARR of n. Now you search for this sum rather than this given sum. Make sense? Anything. I mean, we can add first 2 elements, then find the last element for comparison. Okay, let me say the idea seems very similar, but the thing is, the complexity of this algorithm will be of n square. Okay, if you see, the inside algorithm is O of n, outside you are learning one loop, so it will become O of n square. Two-pointer algorithm is O of n only, because this is just one simple iteration over the array. And why start I minus 1? Because it's a sorted order. You have fixed one sum. Similarly, whatever you did for second, you did for two parts. Think in those lines only for the third one also. You fix one, you go to I plus 1. Even you can start from 0 also if you want, but it is just that you have already explored. I plus 1 is just to avoid those repetitive things. Say suppose I is equal to 1, you might have checked 1 4 combination with that one. Suppose while you are at I is equal to 1, if you start from 0 and check for 4, this 0 1 4 or 0 1 4 combination, basically you'll check it 2 times. To avoid this double checking, we do it I plus 1. That's it. You can start from 0, you'll get your answers, but just that you'll avoid the repetitive calculations. So as we increase the number of elements, complexity will increase. Yes, complexity is going to increase. To the Ankit question, suppose if you want to fix 2 elements, here what we did is fixed 1 element. Okay. Now, if you fix 2 elements, if you want to fix 2 elements, what will happen is, if we fix 2 elements, so we'll write for I is equal to 0 to n minus 1, for j is equal to I plus 1 to n minus 1. For searching, you'll have to write one more loop. So basically, it will become O of n cube, and your your two-pointer algorithm, you can't make use of it if you fix 2 elements. So that's the small difference between making use of those two-pointer and fixing 2 elements. Ankit, am I clear now? Okay. Says Ashutosh, Lalit, did I answer your question? Is that clear? Ashutosh, what about you? I think I answered your question also. Is that clear? Okay, done. Yes, your complexity will now become O of n square if you want to find 3 elements pair. I'll leave this one as homework. What if I say 4 elements? Any quick ideas? Then, yeah, complexity is n cube. We can fix 2 numbers and then 2 pointers maybe. Perfect. So you fix 2 elements and then use 2-pointer algorithm. Complexity will become O of n cube. So all these 3 problems, a pair, 3-element pair, 4-element pair, all these 3 are in the dashboard. You can practice them on dashboard. There or any other platform also. Try to code these 3 things. Okay. So we are done with this one. We'll go to the next problem. Okay. Now, in the previous question, we have discussed one thing. We said, given an array, find the subarray with the largest sum. Now I'll say, find the subarray with given sum. Think for 2 minutes. I have a call to take. I'll take that call and come. Any ideas? Okay, let me give you an example. Today lecture can send it on the group. Yeah, I mean, I have in the group description, there is a link to the OneNote. Every lecture will be in that folder only. Sum is equal to sum plus array. Subarray 1 by 1, ma'am. Yes, that's a naive solution which we can think of. Create all the subarrays. Find sum. What is the time complexity of this algorithm? N square. Think again. You have to fix bounds and you have to find sum also. 1 minute. Okay, take your time. Okay. We wrote a very similar problem at the start of the class. With similar algorithm. So basically it says fix I, fix n, find the sum. So it will be of n cube. Space complexity will be of n. We'll just be using one variable to find. Okay. I think everyone a little bit confused whether it's n square or n cube. Think once again. I'll show you the algorithm. Yeah. So it basically looks like this. You fix I, you fix j, and you iterate from I to j to find the sum of all the elements. I think Ankit is clear now. Lalit, you said the complexity will be O of n. Is it clear now? Okay. Everyone clear that the time complexity is n cube and space complexity is O of n? Okay. N cube is a huge complexity, right? How do we reduce the complexity now? Let's take an example. Let's say we are doing it only for positive integers. Let's not include negative integers. Okay, only positive integers. I said 1, 4, 20, 3, 10, 5 is the subarray, and the required sum is 33. 0, 1, 2, 3, 4, and 5. So, is there any subarray with sum 33? If yes, mention me the indices. 2, 3, 4. Sandeep says 2, 3, 4. Sandeep, Sauram, Lalit. Yes. Yeah. Sum of these three elements is 33. How did you come up with solution? How did you think? Can we reduce the complexity? If yes, how? I'll give you 2 minutes. Think. Hint is that when all the elements are positive, if we keep adding elements, the sum keeps on increasing and we can use two for loops. How will our two loop will be sufficient? You want to say key, we can use two for loops. That's a right answer. But yes, there is one more small optimization. I think what Ankit is trying to say, yes, I understand that one. That's also an algorithm. Let's call this one M3. Let's go with Ankit's idea. What you can do is, you can use a combination of pre-sum. You can use pre-sum, fix I and j, and then subtract pre-sum of j minus pre-sum of I. Something on these lines. Or you can add and subtract elements based on your requirement. But the idea is pre-sum, fix I and j. For fixing I and j, use two loops. Pre-sum will take O of n only. So then the overall complexity will become O of n square. Am I clear, or should I elaborate this method? Because I have used both the techniques, I would think that most of you will get what I'm trying to understand. But yeah, if you want me to explain, I'll explain. Ma'am, explain. Let's just explain. Okay. Someone is there. I'll allow them. So let's say you know what is everyone are clear with pre-sum calculation? I'll come back to M3 again. Let me elaborate on M2. Okay, everyone knows what is pre-sum. Pre-sum of I minus pre-sum of j, or pre-sum of j minus I, whatever two indices, will give the sum of elements from jth index to ith index. Or if we just add nums of or if we add ARR of I plus ARR of j to this also. This is basically one computation. You are just adding 4 other elements, but it's just one computation. If you do this one, if you have an array and I index is here, j index is here, you're saying sum till here, subtract this one. Okay, I will have sum till here, subtract this one. I think if you just add ARR of I, it will be enough. If you just add ARR of I, if you just add ARR of I, we will get the sum between these two integers. We'll get the subarray sum. Right? Abhinay, I'll come back to your question. After this one, I'll come back to your question, okay? You will get the subarray sum. So what I'm trying to say is, do for I is equal to 0 to n minus 1, for j is equal to I plus 1 to n minus 1, write these two for loops, and then use this formula here. sum of the subarray is equal to pre-sum of j minus pre-sum of I plus ARR of I. You will get the sum of the subarray. This is a single computation. These are two for loops. If the sum matches, say that sum is matching. If the sum is not matching, say that the sum is not matching. So basically, a for loop n into n, this complexity will become O of n square, and space complexity is O of 1. See, my question is to say, question was to check whether subarray sum is yes or no. If it's a yes, it's a yes. If it's a no, it's a no. Fine. You can keep increasing the complexity of this question, saying ki how many subarrays are there with sum x, or print the subarrays with sum x. Then you have to store indices, you have to store count. This is a core idea. Extensions to this problem are many. And can you explain the formula once again? Lalit. Okay. So if I say pre-sum of j, we'll store sum of all the elements from 0 to j. Pre-sum of I will store sum of all the elements from 0 to I. If you do pre-sum of j minus pre-sum of I, you will get sum of all the elements from I plus 1 to j. If I add pre-sum of I, if I add ARR of I also, we will get sum of all the elements in this particular window. Lalit, is that clear? Okay, good. Ashutosh, did I answer your question? Okay, I'll wait for your answer. Meanwhile, is this O of n square approach clear to everybody? Okay. Okay. Rishabh says yes. Jahnavi, Prajwal, Shiva. What about Sandeep? I did not see your responses since quite a few times. Saurabh also says yes. Ashish says yes. Okay, Ankit, fine, good. Okay. Now we have dropped the complexity from O of n square, O of n cube to O of n square. Let me come back to 3. Okay. Can we still reduce the time complexity? Hints. First hint is, if all the numbers are positive, if we add any elements, sum keeps on increasing. That's one idea. Okay. And it's already mentioned that it's a subarray. Subarray means you will have to choose contiguous set only. Okay. These two are the important points. Now, think in terms of what will you do if you have to increase the sum, or what will you do to decrease the sum? Think for a minute, then I'll explain the algorithm. Think in combination of your cadence algorithm plus pointers. The algorithm exactly won't be the same, but your ideas from cadence and pointers will come into play. Okay, let me explain. Let's go back to the example. What example did we take? So our arrays 1, 4, 20, 23, 10, 5. 3, 10, and 5. So if sum will be greater, then we increase the, if sum is greater, then we increase the starting pointer, or else we subtract the starting point. Yes. So very close, sir. Good, very close. So let's say I have 2 pointers. Let me call it start pointer, end pointer. Initially, both of them are at the same place. My sum is, let's say, my initial sum is ARR of start. Initially, subarray, if it's a single element, it will be a single element. We need not worry. If I is equal to j, calculate sum to be, it's a first element only. So let's say my initial sum is 1. My required sum is 33. It's more than that one. So now I have to increase the sum. How do I increase the sum? It's a positive element. So, and it's a contiguous array. I have to add one more element to increase the sum. I'll move my end pointer forward. So my new sum is 1 plus 4. My new sum is 1 plus 4. I still have to increase the value. From 1, I can't go and increase. So no other way, the way I can increase my sum is, I have to still push my end pointer. So then I'll do 5 plus 20, 25. 25. Still my sum is not sufficient. Then again I'll push my end pointer. From 20, I'll push it to 3. 20 plus 3 is giving me 28. Then I did plus 3. Now it's 28. 28 is also still less. I need to add a little bit more. Let's say I'll add 10. So this is my maybe say step 2, step 3, step 4. To 28, I add 10. It's 38 now. Okay. If it's 38, my required sum is 33 only, but I've come till 38. Now I want to decrease. If I want to decrease, I'll have to subtract something. I have 2 options. I can move end pointer, I can move starting pointer. If I move end pointer back, it is basically again retracing my same algorithm. If I move front, since it's a contiguous array, I have to include all the elements and I have to include extra elements also. So I'll not move my end pointer forward or backward, that's closed. Start pointer, in this case, I can't move any words back. If I move it back, I am adding one more value for which my sum will decrease. I don't want to do that also. Now my only choice left is I have to move my starting pointer forward. When I move my starting pointer forward, the size of subarray is decreasing. Okay, so basically my end pointer is here, my starting pointer was here, now I'm moving it here. So basically I'm eliminating one value. Okay. What if I eliminate one value? 38 minus 1, 37. The sum is still greater than this one. I still want to reduce. The same logic will follow. Let me move to my next step. I'm moving my starting pointer again. I'm bringing it here. What am I removing? I have to remove 4. 37 minus 4. Now we have 33 and 33. They match. So basically what I'm doing is, when sum is greater, required sum is greater, I move my end pointer forward. If required sum is less, then I move my start pointer forward. No point in moving backwards because already those regions are explored. Backward because they are already explored. Clear with the algorithm, or should I explain it again? Sandeep says got it. Okay. Prajwal says repeat. Okay. Ravishankar also says repeat. Cool. Anyone? What about other people? Okay. Now, I'll wait till here I see some name on the chat which I've not seen till now. So what about other people? I see 10, 15 frequent names. They keep responding, they keep asking questions. But what about other people? What's happening? Okay, I'll repeat. Sure. I'll repeat the algorithm again. Pragati also says clear, Falak says clear. Okay, but I see 2 or 3 repeats. So let me repeat the algorithm. Okay, so I hope everyone have understood the 2-pointer and cadence. Okay, what I'm trying to do here is, the 2 main important points are, since all the elements are positive, to one subarray, if I increase the size of subarray, sum will increase. If I decrease the size of array, sum will decrease. Two important points. Just 2 things. Is this clear for everyone? Increasing the size of subarray will increase sum. Decreasing the size of subarray will decrease the sum. Okay, that's the key point. Okay, what are we doing here is, we have 2 pointers now. We have 2 pointers. This is start, this is end. Start means start of subarray, end is the end of subarray, which we would like to consider and check whether their sum is matching or not. Okay. And when the sum is less, if the sum is less, I have to increase the size of subarray. 2 things I can do. I can move end in this direction. I can move start in this direction. If I move backward, it means that I have already, if I'm moving back in the algorithm, or if I'm moving back the start array, it means that I'm going to the regions which I have already explored. So there is no point in going back. So I'll move my end pointer forward. Okay. If the sum is less, if my sum is too much, if the sum is less, I'll increase my end pointer. If say my sum has exceeded the required thing, now I have to reduce the size. If I move back the end pointer, I have traveled till here because no subarray till here was matching my required answer. If I come back, it is basically retracing the same things again. So to decrease, I'll move my starting pointer forward. In this way, sum will decrease, In this way, sum will increase. Okay. Now let's again try to dry run on the algorithm. Okay. Our example was it's 1, 40, 20, 3, 10, and 5. Our required sum was 33. Okay. Now, I initially start with sum is equal to 1. Both my start pointer and end pointer are here. Okay. Now, at step 1, my sum is 1. Sum is less than 33. I have to increase my sum. So I have to increase my sum. I can't go back from it. I'll go this end pointer, I'll move it forward. So now my end pointer is here. This is my start. This is my end pointer is here. Start and end pointer is here. Already sum is 1. So I have moved the end pointer. So where the pointer is pointing, that index value I'll add now. So sum will become 1 plus 40. Give me 1 minute. Oh, this is not 40, sorry. This is 4. Okay. I have 1 plus 4. Now answer is 5. What is my required 33? It's still bigger. I can't go back from 1. I have to increase the size of subarray. I'll move end forward. What I'll do? 20 plus 5. It's 25. Fourth step. Again. 25 is also not sufficient. I'll move my end pointer here now. So I said 25 plus 3, 28. Still not sufficient. Same reason. I can't go back. I have to increase the size of subarray. I'll move my end pointer forward. And here now. This is my end pointer. It's 28 plus 10, which is 38. Now 38 is greater than required. Now decrease the size of subarray. Okay. To decrease the size of subarray, I can do two things. Move end pointer in this direction or move start pointer in this direction. If I move end pointer backward, we'll basically retracing these steps back again. Okay. So that's a waste of time and that's not how our algorithm should work. So Lalit, yes, even if it's 40, your algorithm will work anyway. Just to show an illustration on how I'll move start pointer and end pointer, I have taken an example such that I'll be able to cover as many cases as possible. That's it. No reason, there is no particular reason to changing it to 4. Okay. Now I'll have to move a starting pointer forward. By moving my starting pointer forward, what did I do? I've reduced the size of subarray, which means I have to subtract the element which I've removed also. So I'll do 38 minus 1, just 37. 37 is still greater. So I have to remove one more element also. For the same reason, now my starting pointer will be here. So my starting pointer is here. Starting pointer, I've reduced the size. I have to move the elements also. I've moved, reduced the size, I have to subtract. From the existing sum is 37, I've subtracted this one, which makes it 33. 33 is equal to the required sum. Then I'd say yes, there is a subarray. There is a subarray of this size. Okay, Ravi Shankar says it's clear now, ma'am. What about other? I think Kapil asked. Kapil, is it clear? Okay. Who else asked? Prajwal, is it clear now? Prajwal. Ma'am, what if? Okay, 20 is 2 times consecutive. If 20 is consecutive 2 times, okay, let's, I understood the edge case which you're asking. We discussed the algorithm. We have dry run on a input which you can find a thing. There will be some things where you'll not be able to find the So there can be two things. You're iterating. Your size of the array is some x, say, something. Your end pointer has come here, but you have moved your start pointer, and come till here. But still you did not find. Then what you will do is, again, start moving the end pointer. But if your end pointer also reaches here, start pointer also reaches the end of the array, still you did not find anything, then you can say that, no, there is no such array. Rajul, did I answer your question? Yeah, he says okay. So how good an how important the algorithm is, equally important is the termination condition. Okay. So I actually thought of discussing bit manipulation also today. We have 20 minutes time. I can discuss the theory if you want me to. If it's too much for today, because we have discussed quite a good number of problems in the algorithms. If you say, no, ma'am, I'll stop. Can you send the code for this problem? Which problem, Ashutosh? Too much for today. Okay. No, ma'am. Okay. So then bit manipulation is a small concept. We'll see where to, we'll finish it on Monday at the start, or we'll find some time and complete that concept. It is a kind of slightly a concept which is different. Generally, it does not happen in combination of other problems. So it's okay. Somewhere we'll discuss that one, or Monday morning, or Monday, the first half of the class, or first half, or 1 hour, we'll do bit manipulation. Okay. So how was today's class? How were the level of problems? Is it okay, or should I lower it down? If you want me to lower it down, yes, I can. If you want me to, I think this difficulty is good enough. And once you know these concepts, technically you should be able to solve most of the problems. At least array problems with these ideas, 2-pointer ideas. And let me name this idea. The last problem which we discussed now, this is called a sliding window problem. I think someone pointed out, I think it was, I don't remember, sorry, I just skimmed through the chat. I think Jitendra, has said sliding window. Okay. These are called as sliding window problems. Difference in pointer and sliding window. See, there is a very, very minute difference, I would say. Here, what happens is, while doing 2 pointers, you're concerned about the element at the start pointer, element at the end pointer. While doing a sliding window problem, you're concerned of elements in between them also. That's one difference. Sliding window, this is an idea, but there will be more complicated problems in sliding windows, where you will have to consider many aspects in your window. Lalit, did I make sense? I'll give you 2 or 3 problems. I'll update on the sheet the problems. Then you'll probably understand it a little bit more better. Yes, but pointer and sliding window are closely related, because in sliding window also you use those 2 pointers to set the boundaries. Okay, best questions for us. Okay, nice. Level was okay. Good enough. Level was okay. Ma'am, can I get the recording of the class for revision purpose? Probably recording is difficult, but in dashboard also you'll have lectures. You will have Bharat sir and Vivek sir teaching the concepts. If you have any doubts of the concepts, you can definitely go back to dashboard and listen that particular concept. Okay, ma'am. So any more comments about the level of questions? Okay. So everyone, you're able to understand the 4 different concepts we discussed today, right? Recorded pre-lectures. I understand, Prajwal. Okay, let me check with the team once again. I'll let you know. Please mention the topic name for our reference. Yeah. So I'll mention the topic names for your reference, but I'll not start with the name of the topic. So today we have discussed about sliding window problems. We have discussed 2 pointers. We have discussed cadence problem, and we have discussed about pre-sum computation. Let me write them down. So we discussed about pre-sum computation. We have discussed about cadence algorithm, and we have discussed about sliding window problem. We have discussed about sliding window, and then we have also discussed about 2-pointer problem. And yesterday we discussed about storing 2 different arrays in a single array. Okay. In a single array. I mean, the exclusive array topics, most probably you should be able to solve with these techniques. Yes, there will be problems with arrays plus searching, arrays plus sorting, all those problems will be there. But when it comes to arrays, the core logics will revolve around these things. Write all the topics, ma'am. Okay. Please write algorithm name. I wrote cadence algorithm. It's pre-sum computation. When we try, then we understand the level, ma'am. Yes. I mean, it'll. Someone is waiting. I'll admit them. Okay. So, if some things are taking key, okay, maybe I need a little bit time to understand these things. Yeah, please go back, listen to lectures, or check the notes again. Rather than all these things, I would say when you listen to the class, you'll get a brief understanding of the algorithm, vaguely, or maybe some bits and pieces you might not be able to understand. The best way to understand algorithms is go take some random inputs, dry run your algorithms. Then you'll understand, this is the reason this step is written. This is a particular reason for writing, which cases, which step is covering. All those things, when you dry run, you'll understand it better. And when you dry run, you'll remember also. It's not like you'll by heart the algorithms. You'll understand why this particular part is done. And I very, very strongly advise you to write the code of all these algorithms. For cadence and sliding pointer, I'll send the codes, because sliding pointer, cadence, they're easy to write only. They're not very difficult. But anyways, for both these, I'll send the codes. Ma'am, how to improve our brain for subarray? See, for any other topic, and if you ask in particular to subarray, I would say that it's continuously you have to solve the problems. You have to solve multiple problems. You have to code them basically. Once you code them, debug your code, you'll understand your mistakes. Yeah, probably algorithm names I'll write at the end of the day. Just remind me if I don't write every day. I'll write it at the end. Tips to debug the code. Debug the code. Okay. So what I generally do is the very brute force approach I'll use is I'll keep printf statements wherever I want. So I'll see the printf statements. I'll have my code already dry run on a paper. I'll see if my code is behaving step by step the way I want to. If it's behaving at some particular location, I'll go and change that code. So printf statement is the best ways I'll use to debug my code. Printf statements and dry running the code. I think, ma'am, companies mainly ask questions based on subarray. See, as far as I've seen, there is no particular topic on which they ask. Yes, generally arrays are frequently asked. Some questions are asked on DEP. There are important topics. But I think subarrays, we have covered most of the things. I'll leave remaining things to explore because we have some other topics also to cover. So, but I'll give you the set of problems which you can experiment. In the problem set, I'll add the questions. Is that okay, Ankit? Because it will be difficult. I mean, Arrays alone, if we keep discussing, we can discuss it for 10 days. But we have time constraints and all these things, right? So we'll discuss the core concepts and you can explore those things. Okay. Cool. Then any doubts in these 4-5 very core concepts of arrays? Okay. I'll wait for 5 more minutes. If you have any questions, you can ask. Otherwise, we'll close it for the day. And happy weekend. Can I remove, ma'am? Ankit, sorry, I did not get your question. Consume time complexity. Can I remove, ma'am? What do you mean? Sorry, can you rephrase your question, please? About your preparation journey on how you study and how much. So actually, while during my classes and all those things, when my lecturers taught me DSA or they have taught me DSA, I have learned all the core concepts. I have an idea on how to do. I know how to debug my code. So I know how to identify mistakes. That was my strength. And from then onwards, I picked few problems. I made sure I covered all the core concepts. I made sure I practiced all those things. I very hardly prepared for 4 months. So, but those 4 months I prepared hard. Like I used to nearly spend 7-8 hours a day to solve the questions. So it's not like I have to, for me, I have to understand the algorithm. I have to get my intuition. I have to write my own code. I have to run it. So every question I do, I never used to forget because I had the intuition. It was not just about remembering the algorithm. And when you keep doing, your pace will slowly increase. And initially, when you're in your initial stages of preparation, it's more, I mean, they'll take a lot of time to solve, but with time it will decrease. But at the start, prefer quality over quantity of questions. So don't see the solution on any other online websites. Solve it by yourself. However you write your code, solve it by yourself. Then you can look at the solution and see whether they made any small optimizations. One very small optimization was straight away we might go to I is equal to 0, j is equal to 0, but j plus 1 will slightly reduce the complexity. Those small techniques, you can go and see them. But it's very important that you write your code on your own. Whether it's right or wrong, it's very important that you write your code on your own. Revised only in 4 months, but we are learning it for the first time. So, see, the way I am trying to teach you is both the kind of revision and teaching the algorithms only. So, there was a kind of latency between the time I have learned the concepts and I was preparing it again. But you are doing it all at once. Even though I prepared for 4 months, it was a repetition for me also. I also learned everything again. So it's okay. That's not a problem. And I hardly study 3-4 hours a day. See, that's what I said. Initially, it used to take a lot of time for me. Like I used to spend 2 hours on some questions also. Only one question I used to solve it for 2 hours. But what I did was I solved it on my own. Gradually, the time for each question you take will be reduced. Afterwards, when you practice for 1 month or 1.5 months, you'll come down to a pace where like you have to take 20 minutes for an easy question, 30 minutes for a medium question, 45 minutes for a medium question. You'll come down to that pace. So not a problem. You guys studying. Same thing happened to my mom. Simple question. It takes 30 minutes to solve. Yes, initially they'll take time to solve. Let them take, but debug your code by yourself. And when you debug your code, when you know your mistake, pakka you'll not repeat it again. So that's the advantage. It's okay. Let things take time at the start. See, 7-8 hours may not be daily. 4-5 hours daily is also a very, very good thing. You have 6 months time, right? I had very, very less time. I had if I speak strictly, I had 3.5 months of time. That's it, not more than that. When you have 7-8 hours, then that's 4-5 hours is also good. And initially only you'll take 4-5 hours. Afterwards, you'll not take 4-5 hours. You'll be able to revise them. You'll be able to do problems very fast. As you're in the initial stages, I told that number, not really. Your introduction. Okay, are you a student about to join Goldman Sachs? Technically, technically, very, very last stages of being a student. You have started from basic. Yes, I have started from scratch. What I'm teaching you today, I have started from that level. So I had only 3 months, so I had to spend more time. When you have 6 months, you can spread it over, not a problem.